Hello, everyone. Hopefully you can hear me. Oh, good. John waved, so we're good. Welcome to the Seagrass Seminar Series. I am Jessie Jarvis. I am the president of the World Seagrass Association. And this series is sponsored in part by the World Seagrass Association and the Planning Committee from the International Biology Workshop 14 group. Brooke Landry has worked in particular very hard to bring this together. So this series, I'm going to give you a little bit of information about what this is, and then we'll get into John's talk, which I know everybody's very eager to hear. So this series actually came out of a request from the WSA membership. In particular, after we had to postpone ISBW 14 in August of 2020 due to COVID, there was a request for us to find ways to continue to come together, to continue to develop our community, and to also find ways to share science and kind of just interact. And particularly because it's going to be another couple of years before we can get together in person for a big seagrass meeting in Annapolis. So we got together with the WSA steering committee and management committee and the planning committee for the ISBW group and came up with this idea for the seminar series. We're going to have a seminar every other month between now and August of 2022. The topics will range from obviously talking today about global monitoring. We will do topics like blue carbon, community of practice for seagrasses, diversity, equity, inclusion, and justice, and even how we can be better seagrass advocates. So all those topics and many more will be discussed between now and August. These talks are recorded. And so if we are a global organization, some of you have stayed up very late or gotten up very early to hear John, which is great. But we know that it's not possible for everyone. And so we have them recorded and they will be posted on isbw14.org. So you guys can find that website. Also, we will be shifting when these happen. So we're hoping to spread these seminar series throughout different time zones. We are a very global community and we want to hear from many different partners. So we will be spreading that out throughout the series. As far as the ground rules for today, there are quite a few of us, so we've not allowed you to talk, but you can definitely chat and we encourage you to interact with John and everyone else in the chat. I will be monitoring that at the end of his talk. And so we'll definitely have a question and answer session there. All right, so let me introduce John and his talk, and then we'll get to the meat of the process here. So John is currently the Tannenbaum Coordinating Scientist for the Marine Geo Network at the Smithsonian Institution, and he's based at the Smithsonian Environmental Research Center in Edgewater, Maryland in the US. He is a marine community ecologist and biodiversity scientist, and he's worked on a variety of coastal systems, things like oyster and coral reefs, salt marshes, kelp forests, but most importantly, he works in seagrass. And his work has really been featured in a wide variety of publications and journals, but also in places like the New York Times, Smithsonian Magazine, and Hakai Magazine. Today, John is going to represent a broad group of individuals, the global seagrass monitoring folks, and he is going to talk about towards a global seagrass monitoring network, the past, present, and future of collaboration. What I'm going to do is actually make him the host. Where'd you go? All right, there you go. So John, you should be able to, yeah.
Cheers, thank you, Jessie. Let me just see if I am able to share now. Okay, Jessie, if you can see that, give me a thumbs up. Perfect, all right, great. Well, thank you, Jessie and Brooke, for organizing this. It's a great idea, I think, in lieu of having the ISBW meeting shifted into next year. So I look forward to actually the number of talks you've talked about, Jessie, which I think I'll hit on a number of these topics too. So there'll be great synergy to come. And thanks to everyone who is attending today, especially those of you who have stayed up late. Thank you, Jessie, for not making me give this at 12 a.m. rather than 12 p.m. And thanks to those of you who are going to be tuning in and listening to the recording. So as Jessie mentioned today, I'm going to talk about this idea of collaboration towards the goal of a global seagrass monitoring network. And in doing so, I'll hit on some of the past collaborative networks that have taken place over the last several decades, highlight some of the current efforts that are underway right now, and give you a little bit of insight into how I at least see the future of collaboration developing on the international stage. So I'd like to just begin by defining this idea of collaboration. And so I just pulled this straight from a Google search, but the top result was the action of working together to produce or create something new. And I would add to this that creation is greater than the sum of its parts. So by working together, we're able to produce something more comprehensive, more expansive than we could have on our own. And I'd like to begin the talk then, and Jesse kind of beat me to this, by just thanking all of you. Nothing I'm talking about today would have been possible without the thousands and thousands of seagrass researchers and scientists and managers and citizens who have been diligently collecting and reporting data for decades now. And so a big thank you goes out to this research community. It's a great one, and I think that we've made lots of good progress, and there will be lots of great progress to come. So speaking of this research, I think we're entering a period of an all-time high in terms of the number of articles and publications that are coming out about seagrass. This graph on the left is from a recent newsletter for the Coastal Estuarine Research Federation that Jesse, myself, Bob Worth, and Ken Heck put together, which show that in the 1970s, there was virtually nothing being published on the topic of seagrasses. And fast forward to today, we're well over 100 papers and conference presentations each year. So this is really becoming an important and recognized field, and there's attracting interest from a lot of the research community. And as many of you are probably aware, the UN Environmental Program released this document here on the right, out of the blue, the value of seagrasses to the environment and to people, summarizing the state of this research, but specifically making suggestions towards improving the management, conservation and restoration in this valuable ecosystem as we move into both the decade of ocean sustainability and the decade of ecosystem restoration. And we've had some really great successes over the last couple of years in seagrass science. This is a project I was a part of that Bob Worth began more than 20 years ago now to restore what is now over 8,000 hectares of eelgrass to the coastal lagoons of the Midwestern Atlantic, which is an absolutely fantastic success story and is highlighted among many of other successful marine restorations writ large. And what's really special about this particular study, I think, is that Bob and colleagues highlighted not just the recovery of seagrass, but also all of these benefits and services that are coming from it. Everything from carbon storage, as Jesse mentioned in the talk, to a really interesting co-restoration of the bay scallops, which was once a multi-million-dollar fishery that went extinct back when this grass was lost over a century ago. And we've even been making inroads into popular media. This was probably my favorite picture from last year. It's an American crocodile in a marine park in Cuba, surrounded by seagrass. I can't tell whether it's upside down or right side up, but the article was really fantastic and highlighted the current state of seagrass science and what it really means for, again, the environment and for people. And you may have even seen this article in Time magazine. There's a chef in Spain, Angel Leon, who is actually cultivating eelgrass and using the seeds to create new dishes in his restaurants. So I think seagrass is not only becoming more prominent within the research community, but also within the public at large. And if it weren't for the pandemic, I would have already booked a table to eat at that restaurant. So seagrass research is at an all-time high. These habitats are now deeply embedded in coastal management and planning, and seagrasses and the benefits they provide are receiving increasing public attention. So this is the perfect time to come together and collaborate. We can coordinate methods and data generation to maximize the insight that we're getting from all this research. And we can make connections so that we're able to share data with local, regional, and national governments so that they can make informed decisions, and educate the public about seagrasses so that we can aid in their conservation and restoration. So as I mentioned, the talk is going to be broken down into three parts here. Where have we gone with collaboration? Where are we now in terms of collaborative networks? And then where are we going? So where have we been? The history of coordinated global monitoring is relatively recent, and we can look to some other organizations and systems that are working towards these goals, things like the Global Coral Reef Monitoring Network or the Mangrove Alliance. As far as seagrasses go, I actually think the earliest representation of an internationally coordinated effort comes from CARICOM, or the Caribbean Coastal Marine Productivity Network, which was focused, of course, as the name implies, within the Caribbean, beginning in about 1985. And there's some really interesting insights that have emerged from that program to the present. And following that, and perhaps under the stimulation of papers such as the one here by Carlos Duarte, which was written in 1999, proposing a globally coordinated seagrass monitoring network, two major programs emerged. There's Seagrass Watch with Len McKenzie, based out of Australia, and Fred Short, who is, I believe, on the call today. So hi, Fred, who began his program here in the US in 2001. And I don't want to ignore the numerous local and regional monitoring programs. There are dozens and dozens of them. I've been deeply embedded in some of the long-term monitoring here in Chesapeake Bay, but I would like to think a little bit more about the global implications and highlight these global networks, whose purpose is, and still is, to establish global baselines that stretch over the period of more than 2 decades now, and to begin to identify trends. Where are seagrasses going, and why are they trending in that direction? And so I want to take an opportunity to highlight SeagrassNet today for the major reason that is in the throes of transition to the Smithsonian Institution and the Marine Geo program. And as part of that, one of our first efforts is to take this massive database of over 100,000 observations constituting 2,000 sampling events over this 2-decade period, and clean it up and make it available, not just for us in terms of the analyses I'll be talking about, but also for the research community. And I would like to give a shout out to our intern, Kirsten Johnston, who may also be on the call today. She's done a wonderful job digging into the psyches of the hundreds of researchers who have contributed data over the years, and trying to get this in a good enough shape to be able to share and analyze. So for those who aren't familiar with SeagrassNet, the program shouldn't come as a huge surprise in terms of the methods. Pretty standard, 3 parallel transects moving from shallow inshore to deep offshore, along which there are 12 quadrats each, all of which are fixed, both the transects and the quadrats. And in each of those, we take kind of standard measurements of percent cover, sheet density, seagrass composition, canopy height, all the kind of standard indicators of seagrass health. And so if part of this quest in establishing these networks is to understand trends, I looked into this large database and identified 54 locations in 15 countries that had more than 3 consecutive years of data contributed. And actually, and I was surprised and very impressed by this, that the mean duration of these sustained surveys is actually 10 years, or an entire decade, with some of these sites, particularly ones in New Hampshire and other ones close to Fred, have been sustained over the entire 20-year period. So this is an incredible effort. I should have mentioned that the surveys are conducted seasonally, 4 times a year. So this really is a commitment that has been made. And so this is a great data set now, I think, to ask and explore what are the general trends in seagrass cover across the globe and through time. And I'll just mention that, of course, these are all data from quadrats. So this is talking about a very close picture of these seagrass beds. I'll speak a little bit later about thinking about things like aerial extent and total cover. And so to answer this question, I did some fancy statistics here. I fit a hierarchical generalized additive model, which we'll get into a little bit more in just a second, across years by site, accounting for those seasonal observations, the species of seagrass that are within these surveys, and weighted by the duration of the survey, so that these longer running surveys might have exert more of an influence in this analysis. So what did we find? This is a kind of interesting plot that I'll walk you through. So the x-axis, pretty obviously just time here, the 2000 to 2020 period. This is a partial plot of the effective year accounting for all those covariates that I mentioned earlier. And on the y-axis, we actually have the deviation from the mean cover across this entire period. And so what we can see is that by and large, there's really no change or no deviation from the mean cover across all these sites through time. But we can see that these shaded areas, these confidence intervals, indicate that there could be substantial variability among sites and species. So I think that this is perhaps the more interesting meat, and we should take some time to explore kind of what's going on in the error bounds of this trend that are leading to this net no change that we see across these 54 sites. So what we can do is break out these trajectories by each individual site. And so it looks a little bit messy here, but I think there are two things to take away from this plot. The first is that cover at most sites is low. The mean cover across all sites in years is about 15%, with the median being 5%. And this generally stays low, which could explain that relatively stable trend. There are also some sites, like this one, for example, that experience pretty substantial swings, declines, increases, and then declines, indicating something that we probably all know very deeply, which is that seagrasses can be very dynamic systems, especially across inter and intra-annual scales. So I thought I'd just take an opportunity to break down a few of these sites to show you that in some cases, sites are decreasing in cover. This may come as a little surprise to those of you who are interested in looking at the impacts of humans, for example, on seagrasses. So here are 3 example plots from Thailand, the United States, Massachusetts, and Belize, showing a decline of 39 to 51% over their survey period. And we can contrast that with a handful of sites that are exhibiting increases, but moderately so. Here's an example from Portugal and Washington State in the US, which have increased their cover about 5 to 12%. And so given the fact that we can see swings up and down within years, across years, we see some sites that may be trending a little bit upwards, we see some sites that are trending downwards. A question that emerges are these losses of seagrass offsetting gains so that we again arrive at that net neutral change? And to get at this question, we have to go back to my high school math classes. I actually spent the weekend doing integration and derivatives, which was crazy, something I haven't thought about in 15 years. But when we think about these generalized additive models, which capture these nonlinear trends, we can compute a derivative between any 2 points or years along this curve to get a rate of change. So this is essentially a linear slope. But we can do this across all years within a site and get an average derivative, which tells us, on average, is this site changing? Is it going up? Is it going down? And we can summarize that information. I would say here, though, across all sites and years, the average derivative is no different than 0, which implies that most sites, again, are not changing through time. And so one question I had is, well, is this finding driven by the fact that we might have rapid change early and then these sites essentially just stay at close to 0% cover, as opposed to a situation where they're not changing at all over the entire study period? So what I decided to do was ignore the periods of no change and just look at the average negative derivatives. So this is when we're seeing a decrease in cover from year to year. And look at the average positive derivative. So this is when we're seeing an increase in cover from year to year. And asking if we just ignore the fact that there's some inherent stability here, are they increasing or decreasing more or less? And as we can see in this plot on the left, the blue points, which are the increases, are generally offset by an equivalent decline, which are the red points. And these confidence intervals, these lines, often intersect 0, implying that even though there are positive and negative swings, that they again average out to be 0. So we have both a situation where sites are being stable or sites are swinging up and down. And in combination between the two of those processes, we again arrive at that flat line over this 20-year period with respect to the change in percent cover. I will point out, though, that there's a handful of sites, I don't know if you can see my cursor, but here kind of in the middle of the plot, where the negative changes are significantly greater than the positive changes. An example would be the Massachusetts site that I showed, or sites in New Hampshire that are nearby. And if we dig into those a little bit, we can see that they're actually reflective of species-specific changes. So these 3 species are the most abundant ones within the SeagrassNet database. And we can see that 2 of them, Cymodocea and Thalassia, are not really changing over this period. You can contrast that with Zostrom rhino, which has experienced an 84% decline since the early 2000s to the present. And that's reflective of change at those sites in places like New Hampshire and Massachusetts. So the story is a little bit complicated by the fact that this overall trend is missing a little bit of the site level variation, but also the species level variation. So there's a lot of nuances that we'll have to address and move through as we continue our exploration of this database. So just a quick summary of what we learned so far from SeagrassNet, that again, the overall cover is pretty low. This could also be a consequence of the study design. So initially sites were selected to encompass both a pristine area that was kind of like the ideal conditions for seagrass, and also paired with a degraded area, so places that were already experiencing impacts and may have had low cover. And we've seen that sites are both increasing and decreasing in cover, such that on average there's no change over 2 decades, and that's complemented by periods of relative stability. And only a handful of sites are declining in cover more than they're increasing. And this reflects species-specific changes, for example, as I just showed, the loss of eelgrass in some of these temperate North Atlantic sites. So moving ahead with this database, I think a really important kind of extension of this analysis will be to relate these trends to both the environment. Fred had a great foresight to send temperature and light loggers to each of the SeagrassNet sites. So those environmental data from these shallow water environments are available, and we will have to work through it. And also potential impacts. So going back and looking at those pristine versus degraded sites, or maybe how particular sites have become more degraded over time. And I've had conversations with a number of groups who are continuing to collect data or have data that they have not yet shared to the database. So we're seeking to integrate those with the intention of, again, releasing this publicly, ideally this year. So stay tuned, and you'll have an opportunity to explore some of these data as well. If you're interested in learning more, we've recently revived the seagrassnet.org website. So check it out. There's not the capability to submit data currently, but we are working on an extension of that and an update that we hope to be able to share very soon. So that's a little glimpse into the past of globally coordinated seagrass monitoring. Where are we now? And I'd like to highlight some forthcoming work from a colleague of mine, Gillian Dunick, who's at Simon Fraser University. She has a synthesis paper of this last 20 years, 100 years of seagrass monitoring data to update the Waycott et al. Paper from 2009, which I'm sure you're all familiar with. And this new paper includes 323 additional data sets, more than doubling that initial analysis. And you can see a map of all of the new sites in yellow here, overlaid with the sites from the original Waycott analysis in purple. So filling in a lot of gaps in places like the Indo-West Pacific. And while the paper is still in revision, Gillian said that I can share this statistic with you, which is based on these data sets, which are from the peer-reviewed literature and considered just the areal extent and its change through time. We've lost about 1/5 of the global seagrass area since 1884. So please keep an eye out for that study. I hope that it will come out soon, and there's lots of really interesting regional trends that are a part of that might be very relevant, and so I encourage you to check it out. I also want to highlight a new effort that many of you may be aware of or already involved in, called the Coordinated Global Research Assessment of Seagrass Systems, or SeaGrass. This is an international working group funded by SCORE, the Scientific Committee on Ocean Research. And you will hear about this again because it has a broad mandate with a lot of pillars of deliverables. But the two that I'll cite here in thinking about synthesis is that the one goal of this group is to establish a standard data reporting schema so that we can begin to bring together data in the same way and make that available. And also there's a desire to synthesize the wealth of seagrass data that exists. And so one way we hope to distinguish from earlier efforts like the Dunick paper that I just mentioned is by explicitly considering data sets that might be unpublished or published in gray literature or have been generated by agencies and would not have been included in some of these earlier meta-analyses. So if you have access to these kinds of data, we would love to hear from you. Please email seagrass@si.edu, and we are happy to involve you in this effort. It will be moving pretty rapidly now that we have a postdoc with Jim Forkiran at FIU, and he will be taking a lead. The first task will be to understand the agreement between in situ observations, like what we get through SeagrassNet, and some of these more remote estimates of seagrass extent and how those changes may track each other over time, and in fact might even be good surrogates for one another over time. So we would be happy to involve the community as broadly as possible. And of course, and this is a topic I'll touch on later too, that all the data contributions will be properly attributed and co-authorship will be extended. And we look forward to building a really great consensus about the status and trends in seagrass globally. I'd like to take a couple of minutes now just to highlight a couple of other current monitoring programs. I've been in contact with a number of folks who are doing really exciting work. These are by no means an exhaustive list. There are lots of really fascinating programs that are out there. I just happened to have the email addresses of these people, and they were gracious enough to provide me a few slides. The first one here is the Indo-Pacific Seagrass Network, run by Lena Nordland and her colleagues. And currently they're working at 24 sites across the Indo-Pacific and engaging over 100 researchers and managers. And they have a couple of goals, including habitat mapping and ecological surveys, like I've mentioned, but they're also focusing on local fisheries and how the health and dynamics of seagrasses are linked with the health and the livelihood of the people who live near and depend on these habitats. I also want to highlight the Asia-Pacific Marine Biodiversity Observation Network, or APMBON, which is led by Masahiro Nakaoka, pictured here. And they've been conducting surveys across multiple habitats, so not just seagrasses, but all manner of coastal systems across the Asia-Pacific region. And Masa in particular has been monitoring sites or coordinating the monitoring of sites within Japan, 28 of them since 2008. And I think this is a really neat data set because what they have done is established a baseline prior to the 2011 tsunami. And their continued monitoring has allowed them to chart the recovery of these systems, which has been slow, but they're now starting to demonstrate positive trajectory, which shows the value of monitoring to capitalize on these unique kind of disturbance events that sadly may become increasingly frequent as we move into the 21st century. I'd also like to highlight the National Eelgrass Task Force, or NET Force, which is part of the Canadian Department of Fisheries and Oceanography, led by Melissa Wan, pictured here. And their goal is to collate all manner of seagrass data in a very synthetic way, as we are doing with sea-grass and Jillian and others have done for previous analysis, to generate a public map of seagrasses in Canadian waters for use in collective decision-making. So they have engaged academics, NGOs, government agencies, indigenous and community groups, and the private sector in a broad attempt to get as much useful and relevant data and input. And I think this is a really great example of how collating data can not only lead to interesting scientific synthesis, but also provides a direct pipeline to people who are using these kinds of data to be able to make decisions and incorporate the diverse perspectives of the people who live in places like Canada on the coasts and rely on this valuable ecosystem. And the last program that I'd like to highlight here, again, by no means exhaustive, but this one's a little bit close to home, which is the Marine Geo Global Seagrass Survey, which I helped coordinate beginning in 2019. And so far, we've received data from 57 sites in 18 countries, which is really impressive considering that, unfortunately, we were hit right in the middle of this program with COVID-19. And so that has really restricted people's access to both field sites and laboratories. So we're kind of in a holding pattern right now, making sure we can accommodate everyone who wants to contribute data, who has collected data, and who might just need to do the last bit of processing to get it to us. And I'd say what distinguishes the Marine Geo effort from some of these other efforts is that we're considering not just seagrass itself using methods that were largely similar to SeagrassNet, but that we layered additional sampling for epifaunal invertebrates, so organisms that are living in and amongst the seagrass, fishes, through a couple of methods, either seines or doing a visual census, and also considering other aspects of the ecosystem. So speculating on the blue carbon component by calculating sediment organic matter, doing ecological assays of predation, and more. And so you can check out all of the protocols that we've made available and data sheets for you to take both into the field and to log and share your data if you wish at our website, which is marinegeo.github.io/seagrass. And there are protocols for other systems there too, which could be interesting as we begin to recognize the interconnectedness of ecosystems along the coastal seascape. And so despite this pandemic, we have got data from, as I mentioned, a number of sites ranging from as far north as Alaska and Norway to the Philippines to Colombia. And you can see here counting invertebrates. These petri dishes here, I think, come from Sweden and have a whole manner of amphipods and isopods in them that have been sieved and are presumably waiting to be ID'd. And so these new pieces of information allow us to address some different questions, in this case, a very simple question, which is how do seagrass characteristics, for example, cover or shoot density, influence the associated animal communities? And we have a couple of hypotheses here, again, very simple. The idea if we have more seagrass or more dense seagrass, that's just more habitat. So we would get more of these small invertebrates and more fish. And another question we can evaluate too is that a lot of these invertebrates, sometimes as much as 98, 99% of them, are funneled up the food web to the fish. And so more epifauna means more food, which could further increase fish abundance. And so right now we have data from 18 sites where all the seagrass, invertebrate, and fish data have been reported simultaneously. For those who know me, they know I'm deeply embedded in a method called structural equation modeling, the diagram of which here is on the right. So I couldn't help myself from fitting one here, which essentially allows us to evaluate this multi-tiered structure, working from the grass to the invertebrates and then up to the fish. And this model accounts for both site and the gear type, so whether it's a seine or a visual census. So what can we learn? The first is that epifauna are positively correlated with shoot density. This is probably not a surprising finding. We have lots of data from this and nice reviews dating back over a decade now, but we have shown it over a much larger scale and from the tropics to temperate areas. And that fishes are positively correlated with invertebrates. So the more invertebrates you have, the more fish you have. Again, not surprising considering, as I mentioned, a lot of these are essentially just fish food sitting on the blades waiting to be eaten. What's kind of interesting that came from this preliminary investigation is that the fish abundance is not really correlated with the habitat characteristics. And in digging into this, one explanation could be is that the larger fishes that we capture in these visual surveys over the span of 50 meters might not necessarily be responding to differences in seagrass habitat on the scale we're looking at them. So 1/2 meter squared, 1/4 meter squared, might be a little too fine-grained to capture some of these. So in looking deeper and as we get more data, resolving how the survey method influences our inferences could be a really interesting question, and one that will guide the development of these coordinated networks moving forward. So as I mentioned, we're waiting on data from more sites, but that hasn't stopped a number of our partners who, when it's safe, are conducting additional sampling this year, which is really fantastic. We've even got student groups into the field, so classes are doing these surveys as part of their university training. In fact, I was in Australia now 2 years ago working with a class in Western Australia to do this. So it's a great opportunity to do a bit of education and outreach. And we're really seeking question-driven applications of these protocols for the future. The primary motivation for this initial round was to resolve a little bit about seagrass food webs and think about the flux of energy through them using some statistical models. But we've had lots of interesting discussions among the group for future applications, ranging from resolving large-scale gradients in herbivory to doing some kind of isotopic analysis to better understand the relationships and diets of these organisms. And really, we'd be very open to hearing things that interest you that could be scaled out to this globally coordinated network. So this is just another invitation to join us. Feel free to reach out, again, seagrass@si.edu, if you're interested in participating or helping to coordinate and propose ideas for the next iteration of the Marine Geo Seagrass Observatories. So those are just the highlights of a couple of networks that are working throughout various regions of the world, and an example from Marine Geo about some of the new insights we can gain from those very simple data that are being collected. I'd like to finish the talk by just doing a bit of speculation and letting you know about some activities that are currently developing that are going to affect the future of seagrass monitoring and collaborative science. So a really basic question is, well, what are we measuring? And those of you who are active in the international seagrass community may have heard of these essential ocean variables from the Global Ocean Observing System, or EOVs, a major one of which is seagrass cover and composition. And I believe these are being finalized this year. They've gone through several rounds of review and input from the global research community, but it adopts a tiered approach that will be familiar to many of you, including things like the extent of seagrass, the cover density and composition, so sort of tier 2, and then also considering some of the services associated with seagrass systems, so carbon, blue carbon, for example, or fisheries, which is a very intense, or I should say more intense, tier 3 approach. And so this framework will just provide some common vocabulary and guidance on how the global community converges around the relevant indicators for seagrass health, particularly from the perspective of management and conservation. And I said I would come back to the Seagrass group. They are also working to derive best practices by incorporating the insights from all of the organizations that you see here that have been a part of these meetings over the last couple of months, but also making an effort to reach out to the general research community. All of you, other communities of practice, which I'll get into in just a second, to really kind of understand what the current state of seagrass survey methods are, and whether we can converge on a consensus about how to measure and report on these variables. And along these lines, I'd also like to highlight the Coastal and Estuarine Research Federation's seagrass mapping and monitoring community practice, which has been around for a few years now. It was originally focused in the Gulf of Mexico and now Chesapeake Bay, but I think the desire is to create a space for the international community to come together to share knowledge, to share methods and insights, to provide support. There's a discourse forum that's available that you can find at this link here that will allow you to connect with researchers that we can help shape how and what kind of variables are being measured and how we can facilitate the sharing of methods and data. And I'll just touch very briefly on the exciting frontier, which is remote sensing. There's been massive interest within the community over the last couple of years in leveraging high resolution satellite data, things like Sentinel-2 and Worldview, to be able to map seagrasses. And this is a major initiative within the Allen Coral Atlas now, being spearheaded by Chris Ralsma in Australia, which is to begin to refine our global maps of seagrass distribution based on this wealth of available imagery. And along these lines, a really important frontier in making sure this can happen is leveraging machine algorithms and machine learning to improve automated scoring of these images. And to do so, we need validation data. And this is where some of these other global monitoring programs like Marine Geo, like SeagrassNet, Seagrass Watch, and others come in, which is to say that these maps, we need to make sure that what we're looking at on these maps is actually seagrass. And the only way to determine that is to get in the water on the ground and generate a point measure saying, yes, indeed, this is seagrass. So it's a challenge to integrate across these scales, but it's completely doable. And this is a map on the right of the entire coast of Florida using Sentinel-2 data. And the green bits are machine classified seagrass beds based on about 32,000 validation points. And this aligns very well with some of the maps that Florida agencies have made of seagrasses, and so could be a roadmap for expanding out into other tropical regions in the Caribbean and throughout the world. I also think that there's a couple of efforts that are emerging considering who's doing this measuring. Right now, I'm talked largely about academics and governments who are monitoring or collating monitoring data, but there's a really exciting frontier to engage citizens and crowdsource some of this data generation. And so a really cool app that I'd like to highlight here is Seagrass Spotter from Project Seagrass folks, Ben Jones and Rich Unsworth and others, where they're encouraging citizens to download the app and go out and take pictures of seagrass, geotag it, and that will give this group a better sense of the distribution of seagrasses, both within the UK, and I believe the intention is to be able to do this throughout the world. And as part of this, we're exploring this platform called Zooniverse to be able to get citizens involved in the process of scoring satellite images and providing training data sets for some of those machine learning algorithms that I mentioned before. And both of these platforms are really great opportunities to provide some material to educate people on the value of seagrasses and why these efforts are important, and which is, as I mentioned, a really important component to getting public buy-in that helps shape the policies that lead to more effective and comprehensive conservation of seagrass. And the final big question that not just seagrass scientists, but I think the global research community as a whole are grappling with is how to share data that we've collected. OBIS, which is the Ocean Biodiversity Information System, is being proposed as a home for all manner of data related to marine surveys, open ocean, to mangroves and salt marshes, to seagrass. So I encourage you to check it out and certainly consider contributing your data to this platform. However, we do acknowledge the fact that data can't, or for various reasons, always be made public. So one thing that we're working with on OBIS currently is a metadata registry, so data about the data. So even if the data aren't able to be made public themselves, this registry would at least allow the community to recognize that they exist. And that will provide some information to connect people to the right data, or in lieu of that, at least to the right people or agencies so that they can begin the process of using or acquiring those data. So I'll just end by answering this question: what can you do as the listener for this seminar? And I'd say that the first thing to do is reach out. Please feel free to contact me or anyone in this presentation who's contributed slides, or anybody in the WSA, or anybody that you know that's a part of an organization. It's an opportunity to contribute your knowledge. You know, I mentioned in the beginning, you know, collaboration is the ability to bring bring people together and create something new, something greater than the sum of its parts. I've been to a bunch of seagrass beds. I still have lots to learn, and I'd love to hear from you, hear about your experiences, the roadblocks you've had, the methods that you've tried and didn't work, because those are really important pieces of information to develop methods that can be deployed globally that do work. And it connects people and networks, and it provides a diversity of perspectives and applications that we might not always be thinking about within our own bubbles. And I think that as we move towards a global community, that making those connections is going to be essential. And the final thing is I would encourage you to share your data. And there's of course this caveat that I mentioned earlier, in that we really are making great strides in being able to provide proper attribution, so that if you do make your data public and somebody uses it, there's a chain of custody, if you will, that leads back to you, and that you're recognized through something like co-authorship. These sorts of data working agreements, data sharing agreements are becoming central to a lot of these synthesis efforts and other platforms for sharing data. And I'm often asked, kind of, what are some of the incentives for sharing data? And I'd be really curious to hear if anyone in the audience has any thoughts. But I think this is an important sort of point to be making, which is what can people gain by sharing data? It does take time to put it in the right format, to upload it, to respond to inquiries about it. I would say from my interactions and from what I've heard people express, there's a few incentives. One is providing context for local observations. So, for example, as part of our marine geo survey, we helped conduct some of the first surveys in the Maldives in the Indian Ocean of seagrasses. And the researchers there really appreciated the ability to fit in what was going on in their islands to what the global status of seagrass is, so that they can go to their government and say, hey, this is a really special place. We have a great diversity of seagrasses. They're providing habitat for important fishes that are part of important fisheries, and they deserve to be considered and protected. It also promotes international standards. I've heard that agencies like to demonstrate that they are complying with international goals and deliverables. Again, it's building community and support. The forum from the surf community of practice is a great place to be able to ask questions about methods. I tried this. I'm not sure if this is the right thing to buy. Getting that feedback, again, I think could be really valuable. And the number one thing that I've heard is that people really appreciate assistance with data management. This is a big challenge, I think, as many of us recognize, and especially as we begin to generate more and more data, being able to manage it properly can be a significant task. And along those lines, another major incentive is assistance in analysis and publishing and reporting. You know, a lot of these networks are keen to analyze data, to help conduct, analysis that will allow you to explore aspects that are relevant to you, that you may not have the expertise or the tools to do. For example, I'm not a remote sensor, but I am very grateful to work with a number of people who are fantastic remote sensors, and who can help me get information that I need to be able to answer the questions that are important to me. So again, please feel free to contact me or anyone in this presentation, any one of these networks, people like Lena or Masa, depending on the region you're in. There are lots out there, and I think we would all be happy to hear from you and help you get integrated into some of these collaborative efforts. And I'd like to particularly thank those of you who've contributed data and slides for today's presentation. Fred Short, of course, for the SeagrassNet data, but also Jillian Dunick for allowing me to speak a little bit to some of the work that she's done on updating this synthesis of global seagrass trends. Lena Nordland, Melissa Wong, Emmett Duffy, and all the rest of the global seagrass community. Again, thank you. This wouldn't be possible without you, and I look forward to the next 20 years of doing collaborative seagrass science. And I guess we're doing questions. Jesse, did you want to? Are there questions in the chat? Okay, I see one. Oh, can I unmute you? Sorry, that would help, huh? Give me 1 sec, Jesse. I will try to figure out how to do that.
Thank
There we
you.
go.
I appreciate that. First off, thank you very much, John. That was a fantastic talk. It was really covered so much information, and it was really very representative of a lot of the work that's out there. So thank you very much. I'm sorry, we're not allowing people to clap for you, so I apologize because we made them quiet.
That's okay. I'm used to it.
But are there? Let's see. So I will go ahead and answer. Anybody have any questions? Please post them in the chat. So far, it's just been a lot of thank you and really great to see all the different programs and future opportunities. So I guess I can lead off with a question for you, John. So with, I know some of the issues sometimes with sharing data are, because I do feel like there's been a lot of success for groups that have been able to share data, mangroves in particular. A lot of the work that they've done and progress they've been able to make is because they were able to get their data together at a big scale. But what do you do about places when you're kind of limited in your ability to share the data? So you kind of addressed it with the metadata. Is there any other way we can get groups from other areas to be able to share what they're doing?
Yeah, this is a really good question. And I think one which, you've mentioned a couple of other efforts, but I think lots of people are grappling with right now, which is when there are restrictions on the data use for whatever reason, and sometimes, this is a consequence of the funder or, an agency policy or something. One option is to be able to make some sort of derived product available. So this is what, for example, the Allen Coral Atlas is doing. They get this validation data, and they are able to make some summary statistics from that, representing maybe where seagrass is or how many validation points there are or something available along with their reports and products. Another thing is that I mentioned that these data sharing agreements have been a cornerstone of a lot of these networks, especially as they begin to move into a phase of making data available broadly, just not within the network, but also outside of it. And I think there's lots of different licenses that exist for data use and attribution. And so being flexible and recognizing that not everyone is in a position to share data in the same way can go a long way in making sure that at least we can get data integrated into these efforts, even if it's not being made available in its complete raw form to the community at the end of these efforts.
Great, thank you. So there's another question. Is there a climate change angle that could be investigated with these different monitoring programs? This is from Bill Dennison, and he's using the loss of Zostra in the Chesapeake Bay due to high temperatures. Are there any other locations that are sort of experiencing a similar climate change impact?
Yes, certainly. I mean, they're probably not on the call right now because it's like 1 in the morning, but folks in Western Australia have had, I wouldn't say success, they've identified a lot of rapid change as a consequence of their monitoring. And I did ask for some slides from that group to answer this very question, Bill. Sadly, they didn't get them to me quite in time. But I think that, Masa's example from Japan is a good one. We can't anticipate these, particularly these pulse events, whether it be a particularly hot year, a tsunami, an oil spill, something like that, and having a monitoring program in the region that can establish the baseline and chart the course of recovery is really important. And I think, towards that end, converging on a set of standard methods, exploiting some of this remote sensing imagery, all of those can lead to a more integrative perspective when these events do end up striking, and we're kind of trying to figure out what is the impact? Should we be concerned?
Chesapeake Bay is dominating. They also added scrolled up. A corollary question would be, we've seen expansion of rupia in recent years. Is this pattern of rupia taking off been observed anywhere else that you've seen?
Yeah, this is a good question. I was going to try to explore a bit of rupia, and I just ran out of time. There are not as many observations of that in, for example, the SeagrassNet or the marine geodatabases that I have access to. Capturing that turnover, though, could be really interesting, especially as we lose kind of late successional foundational species like a thalassia. We might start to see equivalent cover, but of different, more early successional species like a halophila. And so getting that perspective over the course of these long-term studies could be really interesting too, and speculate on the implications for things like, habitats or carbon storage, which I think are really important aspects to recognize how that composition and turnover can influence those.
Another question here, with the vast amount of research papers with different research questions, how would you go about and create international standards? And who decides which metric will be the most efficient to determine?
This is a very good question. Yeah. First, I'll preface it by saying I am not going about creating these standards. For example, the Global Ocean Observing System's Essential Ocean Variables, the EOVs, I believe is a consensus of working groups and international experts who've come together. Fred could probably speak at length about discussions leading towards, what do we measure, at what resolution, do we have fixed transects, random transects, how big are the transects, are we doing percent cover bins, are we doing brown blanquet? Those are all reasonable questions to ask. I think part of these emerging discussions are going to be, in the same is true for data that I just mentioned, incorporating flexibility, incorporating tiered approaches. If the minimum you can do is go out and say, yes, there's seagrass here, that's still valuable information and should be reflected in these standards. If you can get carbon sequestration rates, that's also valuable information, but of course it's a lot harder.
Some more questions coming in. You mentioned outreach as classes and some citizen science, and of course more traditional researchers like PIs that can collaborate. How do you see how do you see sprouting scientists or grad students fitting in and getting their feet wet in global collaboration?
Yeah, this is another great question, and I think this is something that the community can come together to help promote. In the era of COVID, in my experience at least, grad students or postdocs or even undergraduates have been really valuable in helping to curate some of these data sets that exist. As I mentioned, the huge challenge I hear again and again is data management. Oh, we have the data, but it's not really in shape yet. Or we have the data, but it looks different than these other data, and we don't know how to bring them together. I mentioned our intern, she's a postgraduate, she has a bachelor's, and she's been really incredible at digging into and probably knows the SeagrassNet database better than I do at this point. So that's certainly one avenue that I can see engaging them. The other is, as I mentioned, like Lena, Nordland has several students and is leading undergraduate classes and doing these surveys. If it's convenient and there are opportunities to get students outside, I mean, it's not rocket science, right? A lot of it is very straightforward. And as long as they've got good instruction on how to get started, I've seen students do really fantastic jobs at, generating percent cover. I had a wonderful student who counted 20,000 amphipods. I don't know how she didn't go insane, but we got some really significant insight, and she really and she claims she enjoyed it. So I think that leveraging that pool of talent could be a really fantastic path towards being more productive as a community.
We're sort of our last minute here, so I just want to do one last question, and I'm sorry, Rebecca, we're not to get to your question, but Laura asked, how can we connect nature managers and governmental organizations to these networks, since they also have so much monitoring data available but are poorly connected to global scientific communities?
I'm glad this is the last question we're asking on, because I think it's really important. And there are a couple of organizations that are working towards this end. So the SURF community practice I mentioned is one. Connecting managers with scientists has always been a central mission of SURF. But also, like for example, the Pew Charitable Trusts has a national seagrass program here in the US. Their whole organization is devoted towards translating science to decision makers. And so beginning to tap into those those pools of expertise and bringing them into the discussion early is critical. So I mentioned the metadata registry. one thing that we've got from those discussions with those groups is that the objective of the survey or the monitoring program is crucial information. So if people are wanting to connect over similar management objectives or similar sort of stimulants for getting the program started, that could be really useful in helping to fuel some of these more policy type decisions. You know, I'm sure there are lots of people here who could speak to this better than I can. And so I think that just having a frank discussion within the global community and inviting those people to the table is a really good first step.
Great. Well, thank you again. Thank you so much, John, for your time and for answering the questions and for your great presentation. We really appreciate it. It was an awesome way to kick off the series. So thank you very much again. And to everybody else, thank you for attending. We will post the video online as soon as we can. But thank you all. And thanks again, John.
Cheers. Thanks, everyone. Please feel free to reach out. I'd love to hear from you, and have a wonderful rest of your day.